All right, everybody. Good morning again. And let's get started. Do you guys see the screen?
Yeah, we see.
Yes.
All right. So today we're going to continue with the factoring. Okay, so last time we learned GCF and grouping. Okay, so today we're going to learn two other methods of factoring when the GCF and grouping don't work. So we can use another method called trinomial or binomial factoring, which are what we call special factoring methods when these two don't work. Okay, so let's start with the trinomial factoring. So as you know, how many terms are in a trinomial again?
Three terms.
That's right. A trinomial has three terms. So we're going to be using something like this. It's the x to the second plus, for example, 5x plus 6. Okay, so that's a trinomial. And as you can see, we have three terms. Do we have a GCF here? We have a common factor.
1.
One is always a common factor. Anything else other than one?
No.
That's right. We don't have anything else common. The x is not common because it's not here. There's no number other than 1. So this doesn't work. Also, grouping doesn't seem to work here. Usually we need to have two terms and 2, or 3 and 3, two groups of terms, unless we split one of the terms here to make it 4 terms. At this point, we can't group. So this is when we try to use trinomial factoring. So trinomial factoring, in this case, we have a trinomial of degree 2. So if we have 1 here, so basically this trinomial is in this form, the standard form, something like this. Okay, this is the standard form of all trinomials of degree 2. So A, B, C are real numbers. So in the case of a trinomial here, so we have, what is the degree, by the way? What is the degree of this trinomial?
2.
That's right. Degree is the highest power, which is 2. So if A is 1, A is the number here, is an invisible one. And degree is 2. If these two conditions are met, we can immediately turn this into something like this. Two sets of parentheses, and we start each one with x. The reason why we do that, because we have x to the second. If we distribute x times x, will be x to the second. Okay, so immediately turn this into two sets of parentheses. That's the multiplication we need. So basically, factoring is turning additions, as we said last time, additions into multiplications. So you stop these parentheses with x. Now we just need to figure out a couple of numbers here and here, and we'll be done with the factoring. Okay, but again, make sure first you check. You gotta have these two conditions. You gotta have a is 1, an invisible one here, and 2. If you have that, then you can write this right away. If not, if you don't have a and 2 here, then you can't do this right away. We use some other method. Now, let's see how to figure out these numbers. So these numbers basically must multiply to C, in this case 6. Same numbers should add up to B or 5. So we're going to find two numbers.
3.
2 and 3.
That's right. Two numbers are multiplied to C, which is in this case 6. Same numbers that you used here for multiplication, use them again with the same signs you used here. Either add or subtract based on their signs. You must get B, or in this case, positive 5. The numbers you said are 2 and 3. Let's check. 2 times 3 is 6. Positive 2. And we used positive 3 here. Is 5. So that's good. So that checks for both of them. So the numbers we need are positive 2 and positive 3. And that's it. So that's our factoring here. This turned into this. You can double check, multiply these numbers. You must get this. Combine them, positive 2 plus 3. You must get exactly B, which is positive 5. And that looks like positive 2 is positive, plus 2 is positive 2 plus 3 is positive 5, which is good. And that's it. So that's your factoring, usually done in one step like this. Okay, so even though we didn't have a GCF, we couldn't use grouping, we still factored. So we turned this into this, usually done, like I said, in one step. The numbers, usually these you can see right away. You don't have to explain how you got them. You can just go ahead and write them when you see them. It can be a little difficult sometimes to figure the numbers out when you have negatives here. So you may have to play around with the signs a little bit until you get exactly this number and this number. Okay, so that's what we call trinomial factoring. And how do you check? How do you, if you want to check if you got this right, what do you do?
You distribute both
That's right. So you just
numbers to the second
use the form
parenthesis.
method to distribute this. As we said last time, this is factoring. Factoring just the opposite of multiplying. So if you want to go back here, just distribute. Distribute. You can easily go back to this. Okay, so that's how trinomial factoring works. Let's see another example. Let's say x to the second plus 7x plus 12. Another trinomial. Again, always see if there's a GCF first. There's no GCF. We can use grouping. So since it's a trinomial, let's see if we can apply trinomial factoring.
Yeah, I have a question.
Mhm.
Yeah, so the x squared plus 5x plus 6, I can do the second step is x squared plus 3x plus 2x. That 3x plus 2x is going to 5x, right? So I did x squared plus 3x plus 2x plus 6, and x is common, and parenthesis x plus 3
Right.
and plus 2. Yeah.
You're right. So in the beginning, you could, if you split these, if you middle term, you can use grouping.
Okay. Thank you.
You can use this right away. That's fine with you. Okay, so there's another one. So always check if you have 1 and 2. If you have 1 and 2, you can go ahead and use the parentheses. So since we have 1 and 2, that means we can immediately write the parentheses like this. Again, only if this is 1 and this is 2, you can start with x and x. If you have a different number here, then again, it's going to be a different way. And we need two numbers that multiply to what exactly?
12. So 4 and 3.
That's right. Two numbers that multiply to 12.
And they also add up to 7.
That's right. Same numbers add up to 7 or B. Make sure sometimes it's negative. Now it's positive. So if it's negative, it means you have to have a negative here if it's negative. But both are positive now. So again, always try finding these first and then based on these, because we have limited numbers that multiply to 12. It's either 2 and 6, 3 and 4. We figure out which one gives you this and this. And there's always one combination. If you try to use 6 and 2, it will be 12. But when you add them, if you add 6 and 2, you get 8. You will not get 7. But if you use 3 and 4, So positive 3 and positive 4 here, you get 7. So 6 and 12 will not work, but any other combination, only one combination works. So the numbers are positive 3 and positive 4.
Doesn't matter if we write it, which order we write it in, if it's 4 or 3 or 3 or 4, same thing, right?
That's right, it doesn't matter which one goes first here. If you distribute, you combine like terms, you get back to this. Okay, so that's basically how you factor using trinomial. And let's do another example now with maybe some minuses or some minuses here. So it's actually second. And
Can it be -1?
okay, so let's do this one with a minus here. So x to the second plus x minus 12, another trinomial. Do we have a GCF?
No.
There's no GCF here. So we have 1. Check. We have 1. We have 2. That's good. That means we can use parentheses, x and x. So now we need two numbers that multiply to what?
1, 12.
That's right. 2, negative 12.
-12.
B. And same numbers add up or subtract to what number?
1.
2, 1. That's right. The B here is an invisible positive 1. Okay, here B was positive 7, but here it is invisible positive 1, or if it's a negative here, it means it's an invisible negative 1. In this case, it's positive 1. And what numbers do that?
-3 and 4.
Okay, let's try. You said -3 and 4. So -3 times 4. Yes, we get this, -12. If we combine them, if we combine -3 and positive 4, we get positive 1, which is good. We have positive 1 here.
Teacher, can your A be negative, or it should always be positive?
A,
Yeah, like x to the second power.
if it's negative, you can factor the negative out. Okay, if you have a negative here, you can factor by -1, and you make this positive.
I don't understand how to do that though.
We'll get to it. We'll get to some example like that later. Okay, so again, let's double check this. So they multiply to this, and when you combine them, -3 and 4 is 1. If you switch the signs, you'll still get -12 here, but you will not get positive 1 here. If you switch the signs, if you put a negative here and a positive here, this will be a -1, which is not what we want. Okay, so make sure you get exactly C and exactly B. Here's another example. Okay, again, when you see a negative in one of them or two, you gotta be more careful because the signs here, you have to get exactly these numbers. Okay, so for this one, so when two numbers are multiplied to 12, positive 12, and add up to positive 12 here, same numbers must add up to this, -7.
-3 and -4.
Okay, let's try that. -3 times -4 is positive 12, that's good. Use the same numbers again, don't change the signs. Yes, -3 minus 4 is in fact -7. So that's good. That works. So both numbers are negative. So -3 times -4 is positive 12. -3 minus 4 is -7. And again, you can easily check. If you distribute, you will get back to this stage immediately, or to this exact stage here, to the exact expression that you started with. Okay, so let's see another example. Let's say you may have so x to the third, or before that, actually, let's do x to second. Maybe 3 plus okay, so there is another example here. We want to factor this. So what do you think happens first?
Find the GCF.
No, that's right. We see that there is a GCF here. So before we attempt this, before we do the trinomial, let's factor the GCF out. What is the GCF here?
3.
3. So 3 goes into all of them. X is not common. Only the 3 is common. So we're going to find a GCF first, which is 3. And what else? Once you find the GCF, open the parentheses. What do we do now?
Factor x second.
Okay, we need to divide, factor 3 out. So we're going to divide all these by 3. So 3x to the second by 3 will be?
Okay, so 5x.
X to the second plus?
6.
Okay, 5x divided by 3. I mean 15x divided by 3 would be 5x. And 18 by 3 is 6. This is what we talked about last time. We did this in detail, how to find the GCF, divide, and everything. Good, so that's the first step. Always look for a GCF first. Okay, can we factor more?
Yes, the parentheses.
That's right, we have a trinomial here. Again, you have 1 and 2. If you have 1 here, invisible 1 and 2, that means we can immediately say, so 3, don't forget about the 3, it stays there. This will become x and x again, plus 2, plus 3. Two numbers are multiplied to 6 and add up to positive 5. So we used GCF first, and secondly, we used trinomial.
So you would then first, if you wanted to check this, you would first multiply the parentheses and then the 3, or can you do the 3 to the first parentheses and then that result to the second parentheses?
I believe it's better to start here first, distribute the parentheses, and then multiply the 3 over the parentheses. Okay, so GCF is always done first. After the GCF, see if you can factor again. If not, if you can't find the numbers
So teacher,
something else, then you can you leave it like that.
in the first homework, in homework number 9, that it was only asking for GCF and grouping. If we do the GCF and then there's a, do we have to also do the trinomial afterwards?
I don't think so. Just follow the exact instructions of the question. So if it says factor completely, that means you have to factor until you can't factor anymore. If it says find the GCF or something, depends on the question.
No, it didn't say anything, but I was just wondering because now we know how to do it. So I was just.
No, so yeah, this will be from the next homework.
Okay.
Let's do another example here. Let's say x to the third minus x to the second, and maybe minus 6x. Same thing here. We have a trinomial. We want to factor it hopefully into some parentheses or something like this. Okay, so what do we try first?
The GCF.
GCF. Always attempt to do GCF to find it first. Do we have a do we have a common factor here? X. That's right. We have x here, x3, x2, and x1. Which one do we take as a common factor?
X1.
That's right. Only take the lowest one of all the variables. So the lowest one is x1. Okay, open the parentheses. So that's your GCF. So we open the parentheses. And then we divide. So we're going to take all of these, divide them by the GCFs. X3 divided by X1. X2 minus X2 divided by X1 will be X by X1. Negative 6X by X will be negative 6. Okay, first step of factoring is done. Do we factor more? Or can we factor more?
Yeah, you can use a trinomial method.
That's right. We have trinomial inside, so we can attempt to do that. So number 2, trinomial factoring. So again, this X should stay here. Can we do the parentheses here? What do we
Yes.
check again? What do we check before we open the two parentheses?
The A being 1 and to the second power.
Exactly. So we're gonna have 1 here and 2. We have an invisible one, so that means we can do this. And find two numbers that multiply 2.
Minus 3 plus 1.
Okay, so we're gonna
Sorry,
multiply
plus 2.
numbers that multiply to negative 6. Same numbers should add up to negative 1. So we have negative x, meaning we have a negative 1 here. So negative 3 and positive 2 is to check. So negative 3 times 2 is negative 6. Negative 3 and 2, or plus 2, is in fact negative 1. And that's it. So we factored this trinomial, even though it was degree 3, so x was common, factored the x first, then we factored the trinomial into this. Again, you can easily check if you distribute this, you should get back to the expression if you multiply or distribute. And that's pretty much how you do trinomial factoring. Let's see. We're going to do binomial. Going to look at binomial factoring. Okay, so number 2. Any questions about trinomial factoring? Everybody?
No.
How many terms are in a binomial?
2.
Two
Two term.
Mm-hmm.
It's two terms.
That's right. So for example, 3x plus, let's say 6. That's a binomial. You learned how to factor this last time. What is the common factor?
3.
3.
That's right. 3 is common.
Parenthesis x plus 2.
That's right. 3, divide both by 3, you get x plus 6. That's with
It's
the
plus 2, teacher.
plus 2. That's right. That's with the GCF. And sometimes you don't have a GCF. Okay, so the GCF, if you distribute, you get back to this. But what if we don't have a GCF? Sometimes you may have x to the second, for example, and minus 36. Okay, there's a binomial. We don't have a GCF. So we're going to see how to still factor this into something like this, even though there is no common factor. So what do you think we do here in order to turn this into parentheses? With something here times something.
The x's first,
Okay.
and then you
Also
figure out what
parentheses.
two numbers multiply by each other to give you 36.
6.
Okay.
Also two numbers that go 0.
What about the signs?
They have to
X
be
plus 6
positive,
minus
negative.
6.
Yeah.
Okay. X plus 6, x minus 6. So basically you can say that.
So that the 6x and the 6 minus x cancel out.
That's right. So you can say that. So two numbers are multiplied by 36 and So negative 6 and 6. Or you can look at it this way. So we have a square here. We have x to the second minus. How do you write this as a squared, as a number squared?
6 is 2, yeah.
That's right, 6 to the second. You can also look at it this way. So we have 2 squares. We have a minus in between. So what you do, you just take the bases here. Okay, just the bases without the powers. And you repeat the same thing again with the other sign, with the plus sign. That's another way to look at it. This might not always work, but I believe, yeah, so especially if you have 6 here or you have 4, so that might not be as easy as this. So look at it this way, it's better. You want to find, you want to turn this into 2 squares. So that's why we call this actually binomial factoring. It's also called difference of 2 squares. Okay, the difference, because of the minus, of 2 squares. So whenever you have, again, 2 squares, this is the formula for this. So whenever you have, let's say, a to the second minus b to the second, you can turn this into what goes in the parentheses. If we do it just like this.
A plus b times a minus b.
That's right. So if you have 2 squares and you have a minus, okay? Not a plus. If you have a plus, it will not work the same way. So you take the bases, a minus b. And again, here, a plus b. That's the formula, and you can check for yourself. It's easy. You can distribute. You'll see that it goes back to this.
So this only works if it's negative?
That's right. It will not work with the positive. Okay, so let's see. Let's look at another example here. Let's say, okay, so we have x to the second, we have the difference, and we have a square here. You can do this in one step. What is this equal to? If you do it the same.
We have to put 2 x's here into parentheses.
So 2 squares. So this is squared, this is squared. So we can say x.
X plus 5 times x.
Minus 5 and then x plus.
That's right. X plus 5, x minus 5. Okay, so again, you just need to get the 2 squares here, like this, and you can write this in one step. You don't have to go through this step. You can just write it right away. Man, you can, again, if you distribute, you should get back to this. So that's binomial factoring. We use this formula here, which we call the difference of 2 squares. And we can go back and forth between these. Sometimes if it's like this, you can immediately turn it into this. So when you distribute, I'm sure you saw this in the multiplication of polynomials. If you have something like this, you don't even have to actually distribute and combine like terms. If you see something like this, x and x, same number here with different signs, you can immediately go back to this. Just take the first number, square it, put a minus, and square the second number. Okay, without having to distribute, combine like terms. So this is, again, factoring. If you go back, you can do it right away. Factor, if you multiply, if you have this, you want to multiply it, you don't have to distribute, you can turn it into this immediately.
So you mentioned that this is the difference of 2 squares, and that formula only works if the sign is a negative. So does that mean that the sign for whatever examples we get will never be a positive in binomial factoring?
Well, if you see a positive, you know it's not going to factor. Okay, so you may see a question in the homework with a plus here. You know it's not going to factor. Whatever you think you might be the answer, if you think you have a plus and you think there is some answer, check your answer yourself and see if you can get back to that, and it will not work. Okay, so if you see that, just say it doesn't work, it doesn't factor, or say it's a prime or something like that.
Or say it's what?
Prime. prime, when you can't factor something, polynomial, we call it prime.
Okay.
Okay? So factoring is not always possible. Sometimes we can't factor something. Let's look at another example here. Let's say, okay, another binomial. We want to factor this. What do you think happens first?
Find the GCF.
That's right. Always find the GCF. So before we use these methods today, that I said trinomial and binomial, these come after this. These two don't work, but always try this first. Attempt this. Maybe if it works. If not, you see how many terms you have, whether you have A and D, 1 and 2, and you see if you can use trinomial or binomial. So here we're going to try the GCF first. Factor the 2 out. Divide by 2, get x to second. Divide by 2, we get 9. Okay, that's the first step. Anything else? Can we factor this more?
Yeah.
Yes.
That's right. Inside the parentheses, do we have the difference of 2 squares?
Yes.
Yes.
That's right. So we have x squared minus 3 squared. And this will turn into
2x minus
X minus, and then
X minus 3, x plus 3.
x plus 3. Okay, so we used the difference of 2 squares for this one here. And that's pretty much the factoring of that. Again, you can easily check and see. You'll get exactly this if you distribute. So
Professor, I have a question.
Mhm.
This only happened when the binomial is negative?
Yeah, you have to have a minus here. If it's a plus, it will not factor.
Okay.
Okay. I mean, you cannot use this here with a plus. It has to be with a minus. It has to be. It has to be a minus here in order for this to work. If you have a plus, it's not going to be. Okay, let's look at another one. This time, let's say we have x to the 6th power minus maybe 4. Okay, so now you have a difference. Okay, so let's see. First of all, there's no GCF. Let's see if we can apply the rule. So the rule here applies only if you have a minus. We do have a minus. And if we have 2 squares, or 2 perfect squares as we call them, at least we can see that this one can be a perfect square. We can write this as the 4 as a square will be 2 to the 2nd. Okay. Now we're going to see if we can turn this into a square as well. If we can get a square out of this, then we'll be able to use this formula here.
x to the 3rd to the square.
That's right. If you want to get a square out of this, so you say, so we want some square here, but we got to have another power here. That way, what do we do with the 2 powers here? If you have a power here, what do you do?
Multiply them.
That's right. If you remember this rule from before, x to the a to the power b, we times the 2. So here we have 6.
3.
We have 6 and we want 2 outside, okay? Because we want the difference of 2 squares for the formula. So in order to get 6 here, we have 2 here, so this must be 3. 3 times 2, you get 6. If you have some other, say 8 here, then you gotta put 4 and 2, whatever, but make sure you have the 2 outside. That's what we need for the difference of 2 squares. Square meaning 2nd power. And let's write this over here to the 2nd power. And we now go ahead. Can we use this formula?
Yes.
Okay, so what do you get?
X to the 3rd minus 2
Okay.
times x to the 3rd plus.
Okay, so basically, that's right. Once we have 2 powers here, squares, just take their bases, whatever their bases might be, take them, write them here, and write them again with a plus. So the bases here are x3 and minus 2, and they're the two powers, so x3 minus 2, and x3 again plus 2, just like this. And if you distribute, you'll get back to that expression. So difference of two squares, again, just make two squares out of the two. If you do that, then you can apply this immediately to the to your expression, and you get this, which we can distribute easily to give back to the original expression. Okay, any questions, everybody? Everybody on board?
Yeah.
Okay. Any questions?
No.
No.
Let me get some more of the last example that you gave, the last one.
Okay. Everybody else, are you guys okay? Any questions about trinomial, binomial factoring?
No, we're good.
Okay, so as I mentioned previously, we're going to be using this a lot, factoring, in the next few topics. Most of it, or 80% of it, will be basically factoring. We're just going to add a couple more steps to this, but most of the work will be factor first and then solve or simplify either rational expressions or solve rational equations or solve quadratic equations. So it's going to be about factoring. So make sure you understand these two methods and the ones we did last time. That's very, very important. It will make your next two classes a lot easier and faster. Like I said, most of it will be factor first and then do something else. 80% of it basically will be this. And yeah, let's look at another one like this. Say, let's make this maybe make this 8 and minus maybe 9. Okay, so what do you think happens here? So we have a difference.
Turn into parentheses x to the fourth, close parentheses squared minus 3 squared.
Right, so we're going to try to make two squares out of this. At least this one seems easy, so the square here is 3 to the second. And we're going to get a square out of this. Again, we want the square to be here. So we're going to have x here, a power, and 2. What is that power here?
4.
4, that's right. That way, when we times them, we get 8 again, according to this rule that we learned before we did the rules of exponent. Good, now that we have two squares, I'm going to write their bases. So what goes inside the first set?
X4 minus 3.
Right, this base x4 minus 3.
And then x4
And
plus 3.
Plus 3 minus 3.
again, the same thing, but change the sign, so it'll be x4 plus 3. Okay, and that's pretty much how you factor using binomials and also trinomials. Again, these are special factor methods that we use when we don't have a GCF or when we don't have when we can't group. So we can still attempt to factor, which we do. Not everything can be factored. Like I said, sometimes you may have prime polynomials. For example, x to the second plus 5x plus 9. is if you try to find two numbers, right? Try to find two numbers that multiply to 9 and add up to 5. Can you find two numbers that do that?
What does it say there? Prime?
Read that?
Prime. Prime
X
polynomials.
X7?
Oh, prime polynomial.
Prime polynomials, yes. So two numbers that multiply to 9 and add up to 5, that's two integers. You can't find those two integers.
Professor, is that X7?
Uh,
No.
Say again?
X to the second power.
No, that's 2.
X.
That's 2.
That's to the 2.
Oh, that's a 2.
3x plus 2x.
So the numbers, what is it again?
3 and 2. 3x plus 2x.
3x plus 2x.
Mm-hmm.
And what do you do with that? If you split it and you see if you can factor, so we have x second
Plus 9.
plus 9. So if you attempt to factor this group first, you get x
X
plus 3.
3. Yes.
You can't factor.
Yes.
See, there's no common factor here. Okay, so if you can't factor a trinomial or a binomial, you just say it's just say it's
Did you say what? Sorry?
prime. Prime means you can't prime polynomial is something you can't factor. Just like prime numbers, for example, if you have 18, we can turn 18 into 6 and 3, for example, right?
So
we can't break down the 17, right?
So how about we can do 2x plus 3x?
But you
It
change.
doesn't give the number.
Yes. 2x.
It's a prime.
So remember, it's not going to work because remember that whatever two numbers you get has to be able to multiply those same two numbers to get 9 and also add those same two numbers to get 5. So that's why it's prime, because it's not.
So the number is multiplied to this. Same numbers used here. They should give you this without changing their sign. So we call it prime, just like prime numbers. Prime numbers are numbers you can't split, you can't break down like this. Numbers like 2, 3, 5, 7, and so on.
Numbers.
So for example, 17 is prime, 18 is not prime. 18 is what we call composite.
So we can do 2x plus 3x plus 9, right? X squared plus 2x plus 3x plus 9.
No, there's no solution for this factoring. That's what
one
he's trying to tell you.
Is prime. At least with integers. With integers, you can't find two integers that multiply to 9 and add up to 5. So,
Yeah.
okay.
So basically what he's trying to say is just don't factor it. Just say that it's a prime polynomial and there's nothing else to do.
That's right. If you can't figure out the numbers, that's okay. Just say it's a prime. There's another one here. So if you look at this, there's no GCF. We can't apply the difference of two squares. This works if you have a minus here. So whatever you think might be the answer here, you're probably thinking about this, but it's not going to work. You might be thinking about this. That's why I said earlier, don't think about it the way that
it's not going to work because the 3's are not going to cancel out.
Yeah. So if you distribute this, it's not going to be this. Be sure about that. You can check it for yourself. It has to be a minus. That's why it's called the difference of two squares. If you have a minus, then so this also can't factor. So this is also a prime.
Okay.
Okay, it's a prime. You may see in the homework letters here, Q or something. In addition, instead of 5, you may see some letters, whatever. So just work around those letters, multiply and see. Some of them you can't factor. Okay, some of the ones in the homework, no, you can't factor if you can't find two numbers. Or instead of this, you may have Q here or Q squared or something. But again, the idea is that try to find two numbers that multiply to that and add up to this. Okay, it's just a little note. You may come across this in the homework. So, any other questions, everybody? Any other questions about any of this?
No, I think I'm okay.
Okay, so let me give you a couple of these to practice on your own right now. Okay, and let's see. So x to the second plus okay, so try these trinomials and also
What would happen if, for example, a trinomial has two things to the square?
oh, sorry, repeat the question.
Like, for example, it has like two variables that have like a square in the trinomial.
Yeah, so those, like I said, I think you saw that in the homework, right? So
Yes.
just work around them. You can try the multiplication and try the addition. Whatever you multiply, if you add, you should get that, okay? Could be numbers here, 5, or it could be some letter K or Q or whatever number, but the same idea of multiplying. And let's see here. 10 minus, let's see. Okay, so again, most of these, once you know what you're doing, you can do this in literally seconds, okay? You can figure out the numbers quickly. This shouldn't be hard, okay? Take your time, make sure you know how to do this. If not, again, just review these examples and follow the same steps. Okay, work on these and I'll check with you in a few minutes. All right, so what did you guys get for the first one?
X plus 5 and X
Say it again. X plus?
X plus 4, X plus 5.
5, X plus 4.
Okay, and this one?
X minus 4, X
X
plus 4.
minus 5, X minus
X minus 5, X plus.
minus.
It's not going to be a minus 5 because
No,
we
it's
want a 1. We want a positive 1.
4.
I got X minus 5, X.
No, this has to be
No,
X.
X minus 4, X plus 5.
4, X4
Plus
plus
5.
5.
That's right. So we need
-4.
a plus. We need this to be a plus, so the higher one should be positive. And what about this one?
X minus 4, X minus 5.
Yeah.
Minus 4, X minus 5. Okay, so if you multiply them, you get 20, add them, -9. What about this one here?
Do you want both the factoring and the
Let's do it step by step. What is the first step?
okay, so 5 parentheses x squared plus 5x plus 6.
That's right. The first step is to find the GCF. And then?
And then it is x plus 3, x plus 3, x plus 2.
That's right, x plus 3, x plus 2. Okay, always do the GCF first. And here?
So the GCF, x to the first,
That's right, we have the GCF first.
parentheses x squared minus x minus 12.
Minus 12.
Okay.
And the factoring is still x to the first.
Mm-hmm.
And then all the parentheses, x plus 3, x minus 4.
X plus 3, I don't think plus 3 should be x minus
X
3.
minus 4.
Right? X. When you combine them, we need to get -1. See this negative?
Yeah, but if you do, but don't you still have to get the 12 or 3 times?
No, it's not supposed to be 2 though. It's
Oh,
not
not
supposed to be
2.
x plus
4.
You said 3 and 2 or what
No,
number?
I said it's supposed to be 3 and 4.
Oh, 3 and 4. Okay.
That's why it's positive 3.
Right, it's x minus 4, x
And
plus 3.
negative.
Negative 4.
Negative 4, x minus 4, x plus 3.
Yeah.
Hold on. -4, that's right.
Trying to trip me up.
I thought you were talking about 3 and 2, but you're right. So times these, you get this. Combine them, you get -1. That's good.
Okay.
What else? Here.
X squared minus 49, yeah. X
Okay.
plus 7, x minus
X
7.
plus 7, x minus 7.
That's right. That's simple. One step.
Mhm.
What about this?
So 2 parentheses x squared minus 25.
Mm-hmm.
And down at the bottom, 2 parentheses x minus 5, x plus 5.
That's right. So difference of 2 squares. And here?
This one,
X is x
5
5 parentheses power 2
x to the 5th parentheses.
x 5 parentheses to the second power.
Mm-hmm.
and minus 6 square
Minus 6 squared.
Which is x,
and parentheses
which is x to the 5th
with
minus 6.
minus 6
Squared,
x to the
right?
5th
Minus 6
plus
squared.
That's
And
right. Now we have
Yeah,
difference.
x to the 5th.
minus
Yeah,
6
x to the 5th minus 6 and then x to
and
the 5th
x to
plus
the
6.
5th plus 6.
That's right. So you gotta make 2 squares out of your expression. Okay, so that's your trinomial and binomial factoring. Again, make sure you understand all this and know how to do this. You can do this fairly quickly. It doesn't require a lot of time. Just know exactly what you're doing, know your signs. This will be needed, used in the future classes. So the previous lecture, we talked about GCF and grouping in detail. Today we'll talk about trinomial and binomial in detail also. So make sure you understand all those 4 methods of factoring and when to use them. You'll see plenty of these in the homework, so work on that. If you have any issues, let me know. And I suggest
The x squared, I'm sorry. The
Mhm.
x squared one, that's the plus. That was a plus. X squared and the x minus 20.
Here?
That one. This is a plus x.
Yeah, it is a plus, yeah. That's why we used plus
No,
5.
I wrote the wrong thing. I'm sorry.
You wrote the minus?
Yeah, I wrote a minus.
That should be a plus. There is a 1 here.
Yeah.
Any other questions about this, everybody?
Nope.
No.
No, got it.
No.
All right. I'm going to take some attendance first.
Is this going to be on the midterm, all of this, up to all this stuff?
Yeah, whatever we cover will be in the midterm. Again, I posted the review sheet, so work on it.
Yeah.
Everything we cover will be in the midterm.
And when is the midterm again?
Week 9. There's a date. The specific date is in the
Okay.
is an unpackboard with the review sheet.
Okay.
Okay, so let's